Howdy folks! I did not even know it, but a friend of mine collects rocks, and he's been doing it for most of his life. And I guess he has quite a collection. He doesn't try to collect anything in particular, but he has a keen eye. He also has a heck of a collection of arrowheads too. But anyways, the other day he gave me a handful of rocks that he found recently, and this was one of them. It looks like it's just a silica-based base rock here, but it has a black coating on it. Now this is actually a new video. Most of my videos have been from footage from a while ago, but I did do some analysis on some black coatings, and the footage is sparse and missing, so I pretty much have to redo it. So I'm going to actually do this one because I think this would be an interesting sample. Let's take a closer look at it. Here's the rock, and the reason I'm mostly interested in the black coating is it looks a little bit different. It's black, but it kind of has a smooth, more metallic sort of look to it. I'll try to move it around here. I don't have a lot to work with, so I'm going to try to remove it from the base rock, and maybe I'll keep this end here just for a sample. But it looks like there's a line here too, and it looks like it goes through maybe looks like a seam, and there's some on the back here too. So what I'll do is try to scrape everything I can from the surface and maybe even break it at the seam to see what's on the inside. My friend actually found this rock not too far from the Blue Ridge Parkway. Now we have a lot of iron in the area, so I'm assuming it's some sort of iron mineral. There's a lot of magnetite, a lot of hematite, stuff like that. So those would be my first guesses. I'm not going to do a complete analysis on this rock since I have a pretty good idea of some possibilities of what it might be, especially since it's probably an iron mineral. But so what I'm going to do is, there's really not a lot of sample to do a lot of physical testing, but I should be able to check the hardness. So I'll go ahead and do that just because it's easy to do, and I'm not sure if it'll give us a lot of info or not. Then I'll remove the coating from the base rock, and hopefully won't hurt myself in the process. Then I'll check for magnetism, and if it's highly magnetic, it's most likely magnetite. If it's not magnetic, I'll take a piece and I'll actually heat it, and then test for magnetism. And if it's hematite, it actually becomes very strongly magnetic. It's quite dramatic. So we'll give that a try. And it'll also have a reddish streak, so if it's reddish streak and becomes highly magnetic, it's most likely hematite. We can also do a borax bead. And if that comes out red, that's indicative of a manganese mineral. Same thing if we do an oxidation melt and it comes out to have a blue-green coating on it, that's one of the manganese minerals. You can go ahead and check out one of my videos that I have about manganese minerals and manganese testing for more information on that. And finally, we can dissolve the coating in acid and do some wet chemistry tests. Check it for iron or maybe something else depending on what we find with the other testing. So let's go ahead and get started and see what we can find out. Let's go ahead and test for hardness with our hardness picks. These are actually rated by the Mohs hardness. And let's start with the number 4. And we're going to see if this will scratch the coating on here. I'm sure you can't see anything on camera, but I see a little bit of a line there, but I think it's actually the metal of the pick on the coating. I find these tests to be a little subjective. Let's go up to a number 5, which is on the other end here. We'll see if that scratches. Well, I kind of see the same thing. So let's go up to a 6, see if that scratches. No, that might be a little different story there. Yep, I think that's a 3-dimensional scratch into the coating. Let me try 7. Yeah, definitely see one with 7. So I'd say it's around a 6. Let's see if I can get some of this coating off. Looks like here's there's a few flakes. Well, that's a nice little piece that came off. Not getting, doesn't look to be easy going here. Alright, we're getting a little bit off of here. There was one good piece that flew off here somewhere. But there's not a lot here. You can see the inside of the rock has this color variation. I got the major pieces out of there. I'll go through this fine stuff inside. Now we have the fun job of separating out these different pieces here to make sure I have enough for the test. Well, this is kind of tedious, but I'm getting quite a bit of material out. I guess relatively speaking. Plenty to test, I think. Let me take a picture and show you what we have. It's pretty much a mix of the base rock, which looks like to be quartz. Some of it is actually pretty clear. Most of it is actually has a lot of orange color, probably from iron that's in there. And you can see some of the black specks from the material. It's not on our list, but we can make one observation after breaking it, and that's the fracture pattern. And to me it looks kind of, some of it's kind of conchoidal, some of it's uneven, some of it's in between. So I guess I would call it subconchoidal. And I'll put some pictures in here so you can look for yourself. Let's go ahead and check the magnetism of our material. I have the larger pieces here and the smaller pieces here. This is just an ordinary magnet. And let's put it underneath here and see what kind of reaction we get. Now if this is hematite, it's not going to be magnetic, but if it's strongly magnetic, it's going to be magnetite. Well, I don't know how well you can see it, but it's kind of moving around, but it's not really sticking to the magnet. I mean, it's definitely having an effect, but boy, that's sure not like magnetite, that's for sure. This would be all over the place. But yet there is definitely magnetism, a magnetic interaction there, so I'm not sure what to think about that. Let's check the larger pieces here. That's even, I mean, they're moving around, but once again, that's even less less affected. I'll tell you what, I have some magnetite, so let's go ahead and check that and just get a good comparison. So I'm going to put these to the side. Alright, I have some magnetite crystals and actually some powder here that I did for another experiment or for another analysis, so we'll check to see how that compares. Okay, here's the crystals, and holy cow, look at that. I mean, that's definitely strongly magnetic. In fact, it's hard for me to move the magnet on the paper because there's such an attractive force there, and there's not really that many crystals there. So, boy, that's definitely not magnetite, because this is really strong. Let's check the powder. Holy cow. I don't know if you can see it's standing up. It's following the magnetic field. Once again, it's hard for me to move the magnet because it's really stuck on there. So that's quite interesting. It has some magnetic properties, but nowhere near like magnetite. So maybe it's something else, but there's a little magnetite mixed in, or maybe it's something totally different. Let's try one other unplanned observation. We'll go ahead and check the fusion since I have the torch out and the material here. Basically, we heat it and see how easily it fuses or melts. You're going to have to take my word for the results because it looks like it's going to be a little difficult to try to take pictures. So, okay, I don't see anything happening, and I got it pretty much red hot. So I did look at it pretty close to see, so I can compare before and after. Here's a piece of our material. It's slightly affected by the magnet. Okay, it will stick if you get it right up there. Let's go ahead and put that on the charcoal block and heat it. Alright, I don't know if the camera's picking that up, but it's turning nice and red hot. We'll let that cool down for a second. Okay, there's the piece of our coating. Well, it's a little more magnetic, but certainly not strongly. It's having more of an effect, but I wouldn't call that highly magnetic by any stretch of the imagination. Boy, that's certainly not what I see with hematite. In fact, what I'll do is I'll put some footage, some video of me doing this test with hematite, and you'll see the difference. So something's going on, but not what we would expect with hematite. Hematite and ilmenite are not magnetic. Here's a sample of our rock, and you can see it's not picked up by the magnet. So I'm going to put it on charcoal. It's supposed to become heavily magnetic upon heating. I know this should work. I just never done the test, so I want to see what it does here. So we're supposed to heat it on, or try to fuse it on charcoal with more of an oxidizing or a reducing flame. Alright, well, that should do it. Let's see what we have. Grab the magnet. Whoa, look at that. It says it's supposed to be strongly magnetic, and it sure is. Let me take another look at that against the white background. Oh yeah. Well, the magnetism test didn't really give us a warm and fuzzy feeling that it was definitely either magnetite or hematite. So let's go ahead and do a borax bead and see if it might be a manganese sort of material in there. If there is manganese in it, it will give us a very dark bead, a dark red, and it may even turn black if you get too much of the mineral in it. So what I actually did is I actually ground up the material into a little powder here so I can get smaller amounts at a time. So let's go ahead and make a blank bead and make sure that looks good, and then we'll put a little material on and see if we can get a red color. I switched wires because I think the last one had some contamination on it. You see, this is getting to be a pretty clear bead. So I'm going to go ahead and add a little bit of the mineral to it and see if it turns that dark red. Alright, I got mineral on there. Well, that's kind of interesting. It's actually a greenish bead. I don't know if you can catch the color, but it's definitely not red. I'll try adding a little more mineral and see if the color develops. Well, here's the bead. I put way too much mineral on it, and it got really dark, but it's still green. When I put the first time I put mineral on it, it was a lighter green, but it's still green, and even though it's dark, but I really put way too much on there. I could tell. I'm not even going to do the fusion because it would definitely be red if there's manganese there, but there isn't. So I guess we're still have a question mark on what this can be. We have a fair amount of information about the coating on this rock, yet we still don't know what it is. The hardness is about 6. It seems to be infusible or nearly so. It's not strongly magnetic like magnetite, so that rules that out, yet it does have some magnetism to it. Nor does it become strongly magnetic when you heat it, like hematite would be. We also ground up some of the coating, and it didn't turn red like a red streak like hematite would have, so that kind of rules out hematite also. We did a borax bead to see if we got a red color, which would be indicative of one of the manganese minerals, and we didn't find that. Instead, we came up with a greenish kind of iron colored sort of borax bead. So with all those avenues that didn't pan out, I guess we're going to have to dive into the abyss of wet chemistry. So I did weigh up some of the fine material that I separated, and that's about 1/4 of a gram, and we'll try to dissolve that in acid. And being a, I'm still guessing it's an iron sort of material, and those seem to dissolve pretty consistently in hydrochloric acid. We'll try putting some hydrochloric acid in here and dissolving it. I don't expect everything to dissolve because there's a lot of sand that's mixed in here, or the quartz that was with the base rock, and some of the base rock is still stuck to the little pieces here too. So, and I don't expect the silica-based material to dissolve. So, anyways, we'll go ahead and see if we can get a good bit of this into solution, and maybe we can do some testing and figure it out. Okay, here's some hydrochloric acid. I don't see any bubbles or anything. And maybe turning slightly yellow, so let's go ahead and heat that up. Alright, you see the color's changing quite rapidly. We're starting to get a little bit of bubbling, so I'm going to put some lead acetate paper to check for hydrogen sulfide gas to see if it's a sulfide. Alright, you see quite a bit of steam coming out of there. So if there was hydrogen sulfide coming off, and if that was a sulfide, that would be turning dark, and it's not. So we don't have a sulfide there. Let's go ahead and test what dissolved here for iron. And it looks pretty dark, so I'm going to dilute that down a bit. I'm going to use maybe like a half a drop and about 5 drops of water. I'll also add water up here as a blank. So here's our coating, here's our blank, which is just plain water. And this side we'll test for ferrous iron. And nothing there, it should turn blue. Alright. Looks like we got quite a bit of ferrous iron there. This is for ferric. Nothing in the blank. And quite a bit in the sample. So this thing's loaded with iron. Quite a bit of iron. I did some thinking, trying to think of where to go next with this thing without doing a full-blown analysis. And I have one idea. I won't tell you what that idea is until we do the test here, but we need to do a soda fusion 6-to-1 with the mineral. So let's go ahead and do that. I'm glad I saved a fair amount of mineral here. So I'll take a small scoop and 6 scoops of this sodium carbonate. I'll get a fresh spoon. Okay, 6. And we'll grind that up really well together so it has good contact to react. Looks like we have more than enough material here to do a fusion. We're getting it melted into a nice ball. Now that it's getting really hot, the volume is reduced quite a bit. Alright, let's let that cool down. Let's get that off of there. Let's go ahead and grind up this fusion. I'm going to save half of it, just in case I need it. The other half I will put into a tube. We're supposed to add sulfuric acid and heat it. Alright, I heated that for a minute or two. I'm going to let that cool down, and then I'll add a little bit of water, and then I will centrifuge it to get the undissolved material out of there. The next thing we're supposed to do for this test is to add a little bit of sodium ammonium hydrogen phosphate, also known as microcosm salts, and it says a tiny amount. Alright, that's a tiny amount. Now we add some hydrogen peroxide, and if we get a yellow color, it's a positive test. Oh, eureka, look at that. In fact, that's very, very dark. I just added 1 drop of peroxide. Wow, it even gets deeper with the second drop. We have our answer. The mystery is solved. We know who the murderer is now. All right, we are done. And here's a summary of our results. This first line is the properties of our unknown black coating. It was infusible, the fracture was subconchoidal, the hardness was 6, it was weakly magnetic, it had a black streak, it was not a sulfide as we tested with the lead acetate paper, it did contain a lot of iron, it did not contain manganese, and that last test was for titanium, and it contained a whole bunch of titanium along with the iron. So let's go to our possible candidates here on what this might be. The first one we were thinking was magnetite, and as we talked about, we knocked that off because it's not weakly magnetic, it's strongly magnetic, and it doesn't contain titanium. So that's pretty well takes that out of contention. The next one was hematite, and as we just discussed before, it did not become strongly magnetic upon heating, nor did our sample have a red streak, and hematite doesn't contain titanium, so that further throws hematite out of the race. One other one I was thinking about that is magnetic, and it can be weak or strongly magnetic, is pyrrhotite. But that's easily fusible. It does have it's softer, it has a hardness of only 4, and it is a sulfide. And it doesn't contain titanium either, so being magnetic, I thought it might be something to consider. And here's manganite, and I just put this up there for, there's a number of manganese minerals, but in this case the fracture was more uneven. It's a little bit softer, it's not magnetic. Some of them do contain iron because there's a lot of cross-contamination there. But they all contain manganese, and our sample doesn't. And it doesn't contain titanium, while our sample does. So the manganese minerals are out. So since we're looking at titanium, I was thinking, well, maybe rutile. So that looks close. The thing is, it's not magnetic, and it has a light brown streak. It doesn't have iron in it. So that kind of takes that one out. So the one last one that I had a hunch about further on down the testing is ilmenite. And that is it's a black mineral. It's infusible. It has a fracture that would be similar to the subconchoidal fracture pattern. It has a hardness of 5 to 6, so that's within that range. It's actually weakly magnetic, which matches. The streak is black, which matches. It's not a sulfide. It does have both the iron and titanium and no manganese. So there we go. We have our answer. I like it when I'm surprised by the results, and that one definitely surprised me. Most of those other materials I mentioned are pretty common, but I guess ilmenite is quite common too. I just never looked for it, nor have I tested for it. I also like when I have very definitive results, and this test came out really well, being very prominent in iron and titanium, and having all the same physical properties and other properties that we tested for. Really gives me a good feeling that this stuff is ilmenite. Well, thank you for watching another long video. For a while there, I thought I was going to have to guess that it was Professor Plum with the lead pipe in the laboratory. But it actually was an iron titanium oxide ilmenite. Well, thanks again, and good luck to you with all your rock and mineral identification.